All right, so let's take a look at the lab that y'all are doing tomorrow. Is that right?
Yeah.
Okay. Thursday. Thursday, yeah, Thursday. Okay, so you'll be using the 7-segment display, and it'll have. We'll learn about active low, what that means. We'll learn about the case statement, and we'll see how this 7-segment display works. To me, it's kind of interesting the way it works. You can use the 7 segments to make pretty much any letter or number you want as long as you're creative about it and say, okay, yeah, I'll agree that that's a B sometimes. And if I put something else on top of it, it makes it a 6. You'll have those. So you can make all the hexadecimal numbers. Now, what's interesting about the 7-segment display is that the way it's set up, you can really only display. You've got 4 displays, numbered 0, 1, 2, 3, and you can only display on one of them at a time officially, but you can use the system clock to have it like display them like sequentially so fast that your eye can't tell the difference. Dr. Trahan does not do that in his labs, but you might do it next semester. Or you might not, or if you're interested, you could go through my old videos and find one of the ones where I talk about how to do it. Good luck with that because they're very poorly organized, and it's probably in some video dated. This has the title of something very useful like March 12th. But anyway, it is there. If you are interested, I can show you. The case statement, y'all use case statement in other programming languages? The C++ have case? I can't remember. At this point, I've done so many different languages, I can't remember what each one has. It's like a bunch of if else's all built in together. But it's easy. So your job is to write the Verilog code for the circuit M described below that will take 4 inputs that can be viewed as 2 vector inputs x and y, and you'll have 11 outputs, which are the vector A and the vector C. And based on x and y, it'll choose a display and it'll choose a character. So I recommend, it says you have to do the Verilog code ahead of time. I recommend definitely that you do that, and also that you do the constraints. So we're going to do something very similar to this. We're just not going to do exactly what it says right there. And I'm just starting from scratch so that we can see any mistakes that I make. We can figure them out. Before we do that, let's talk about the 7-segment display. You'll have in the constraints file, you'll see seg0, seg1, seg2, and so forth. I think it's in that order. Let me pull up the constraints file and see. Let me go ahead and start Vivado and get the constraints file. So I'm going to create project. Next. And I'm going to name this so specifically that when I'm looking for it in the future, I'll know it. Lab 9, 2741, fall, except I might not be doing this anymore. I don't know. 2024. Next. It's an RTL project. It is in the Arctic 7 family. It's 236. It's speed -1, and it's the middle one. Finish. And I'll go ahead and add my source, and I'll call it very descriptively, I will call it Lab 9. I'm actually going to be, what were our two inputs, X and Y? I'm going to put them in here just for fun. And most significant bit I'm going to have as 1, and least, most significant bit will be 1, and least significant bit 0.
So we'll have to define the range of values when we actually code this.
Right. And you're going to see I'm going to do something different with C, and I'll explain why in a minute. So C, I'm going to have, that's going to be my output, and I'm going to have its most significant bit be 0, and its least significant bit to be 7. I like to put the decimal point in, even though it's not required, because whenever I do this, if I don't include the decimal point, it just lights up, and so I always have a decimal point. It doesn't seem to happen to other people, it's just to me. I don't. So you can do 0 to 6 if you want. And I'll explain why I'm doing this in the opposite order in a minute. And I'm going to put one more in here. I'm going to put A, and it's an output. And I'm going to have its most significant bit being 3 and least significant bit being 0. And I'll show you what that looks like. So what it did, and I usually don't do this, I usually list my inputs and outputs in the parentheses and then have them listed as input output later on in the program, but you can do it all at once, and so here it did it for me.
Oh, so that it just starts the code for you? Okay.
Yes. Yeah. And if I had not checked bus on there, and it would just be variables and not vectored symbols. And now I'm going to make my constraints file.
If our display is 7 segments and not 8, but we want to do C is 1 to 7,
the reason I did 0 to 7 is because that's what I was talking about with the decimal point.
Oh, okay.
Yeah. So it's 7 segments plus decimal. So if you were not using that, then I would say 0. I think 0 to 6. I'll verify that in just a second when I look at the constraints. I've put the constraints on the Moodle page, right?
Yes.
Okay. We could always look at 2023 taxes. That'd be fun. Wrong one. Okay, so when I scroll down to or scroll up to, why are these not commented out? When I scroll up to the 7-segment display, I see they're actually not commented out. I guess I maybe saved the wrong one. But see how it starts with seg 0, seg 1, seg 2, seg 3. And so I just use those as well. And then usually I just use seg and not C. But since the instruction said to use C, I'll use C. And I make the decimal point C7. So I'll do a let's see. Move myself. Can I do that? Replace. There we go. Replace. Find what seg replace with C. Skip that one. Replace. There we go. Okay. So, not quite as lazy as just using the variable seg, which is what I normally do, but still relatively lazy. And then I just made that decimal point, I made that one C7. You can leave that one out if you want. These AMs, they're going to be your A's. So they're in your constraint right after the seg. And the A's are what tell you which display you're going to use. Okay, so now let's go back to the 7-segment display. So these all correspond to numbers on the board as well that I don't know what they are. They're there in the constraints. Pin V8, pin U5, pin V5, pin U7, all of those things. But what I remember is I remember them as this is 0, 1, so just going around 0, 1, 2, 3, 4, 5, 6, and the decimal place is 7. And so since I know that I know going around is like that, it makes it easy for me to define a string that makes a certain character. So for instance, let's say I want to have the character 2 with a decimal point. Now, this is active low. So that means wherever I want it to shine, I want a 0. And wherever I want it not to shine, I want a 1. So when I write this, and this is why I made my string go from 0, 2, 3, 4, 5, 6, 7 to go from 0 to 7, because this is the order that I think of it in. So starting with 0, I want the 0. I want the 1. I don't want the 2. I want the 3. I want the 4. I don't want the 5. I do want the 6. And I do want the 7. And so that would mean for this, if I wanted to display this, then I would have C equals 7B 0010010, and that would make my output C be that string. Now, depending on which display I wanted, I made A go in the normal order 3, 2, 1, 0, and I believe that is the order of the displays, but let's find out for sure.
What is the purpose of having that B in the string?
Say it's binary, because if you wanted decimal, you'd put D, or hexadecimal. Why can't I not move that? I don't want to log out. I just want to get to my classes, which are hidden behind me. Is anyone in the Zoom? There's no one there. It's the Zoom that will never end. That was 2020. So if you go to Lab Resources, you will find the BASIS reference manual. It's also very easy to find by Googling. And if I look for the 7-segment display, here it is. And so it has the more information about it, and I can see right here it is AN0 is the rightmost, and then 1, and then 2, and then 3. So that does confirm for me which one is the active one. So if I want to display on the display that's all the way on the right, I would make A equal to 4B1110, because it is also active low. And so you put a 0 in the place where you want to have the display. All right, so now let's go back to our Vivado. And let's see, I have some other things in here that are not commented that should be commented. So I'll comment those, and I'll need I'll have this be X0. I'll have the one all the way on the right be X0, and the one right next to it as X1. So that makes my last two switches X1, X0, and I have them in that order so that they're correct for binary numbers. So having the one on the left be the most significant and the one on the right being the least significant. And then I'll skip the next switch. So I'll skip the third from the right, and just so I have a little buffer zone. And then I'll make the next ones Y. And I'll have, so the one that was originally switch 3, I'm going to turn that to Y0. And the one that was originally switch 4, I'll change that to Y1. And I'll uncomment them. On the file that the constraints file that I posted for y'all, did it have some things that were like already uncommented, or were they all commented? Do you know?
Everything seems to be okay.
Everything is uncommented or commented? Do they all have a pound sign in front of them? Okay.
I was thinking double selection.
Okay. All right, so I think I have my constraints. I normally do my constraints last, so that was unusual for me. All right, so now let's see how we're going to set this up. So we have our inputs and outputs already. So what do y'all want to do? How would y'all start this?
Should do some always blocks, right?
I would do an always block, and I think I'm just going to do one always block. So I do always at, and always at what?
Would you put your input, or would it be the output that goes?
I'm going to put my input. Probably don't need a begin, but I'll have one just in case. What do I have wrong? Oh, I have it after the end module. Okay, so then inside my always block, I'm going to have two case statements. So I'm going to have case, and my first case statement is going to be based on X. And X has 4 possibilities, so I'll have 2 B 0 0 colon, or do I have that backwards? Is it 2 apostrophe B? Did I do that wrong? I can never remember the order of these. You'd think I would know by now. Nope. Yep, that's it. 2 apostrophe B. Did I do it wrong in the OneNote? No, I did it right there. Okay, so 2 apostrophe B 0 0, 2 apostrophe B 0 1 colon, 2 apostrophe B 1 0 colon, 2 apostrophe B 1 1 colon. And then if these were going to be more than one line long, I would have begin and ends with them, but they are not. They're just going to be one line long. I'm going to indent these. And because they're just going to be one line long, I'm going to put them all on the same line. So I'm going to say X, do y'all want X to define our character or our place on the display board? Doesn't matter to me.
Place on the display.
All right. So, and I'll have it be just like the 0, 1, 2, 3. So I'll have this be that A equals 4 apostrophe B 1 1 1 0 semicolon.
And selects the rightmost because it's the active mode.
That's correct. And then 1101 will be the next one. And then 1011 is the next one. And 0111 is the last one. And if I were not using all of them, all of the possibilities, so if I did not use up all of my 0, 1, and so forth, I would want to have a default here. Sometimes it's not a bad idea to have a default anyway, and I can put a default A equals 4 apostrophe XXXX, and the X's are don't cares. And then I'll have an end case. Oh, I forgot my B, 4 apostrophe B. And now everything is wrong. Oh, okay. So this is an error that actually means something. Procedural assignment to a non-register A is not permitted. That actually tells me what my mistake is.
It's define it, reg, output reg.
Yeah. I might as well go ahead and do C up here as well. Now, I could, if I wanted to, like, if instead of having, I'm going to do this just to show it, to you. So I'm going to, instead of having this as a vectored signal, I'm going to have this as Y0, Y1, and let me go into my constraints. Why is that a problem? Oh, because they're commas because they're inside the, they're inside the thing. And so I'll change this to variable Y0, Y0. And I'm just doing this to show you how it works, Y1 and Y1. So now, what I can do in my case statement is if I want to treat Y0 and Y1 as if it was a single binary number, then I can use these curly brackets here, and then I can put in Y1, comma, Y0, close curly brackets, and what that does is it sticks them together and it allows me to treat them as a single binary number. So now I can do the same thing that I did up here with X. But this time I'm going to have it define what character I want it to be. One of the reasons for doing the default is if you don't do a default, sometimes the compiler will throw an error. Even if you know there's no chance you're ever going to get to a particular value, it doesn't know that, and if it has, it might give you a mistake. So I have mine set up to be 8 bits long. Your assignment really just says to use 7, but I find if I don't turn the decimal point off, it just comes on for me. I don't know why. Okay, and also what happens is if you run yours and everything seems to be working right except your characters just look funny, probably it's a mistake in this 07 or 70. You probably need to change the order that you have it based on how you set it up. So I'm going to have, if I have 00, I will have this be I'll have them all on. 1, 2, 3, 4, 5, 6, 7, 8. And then if it's 1, I'll have that be a lowercase r for Rebecca. So it'd be 0, 1, 1, 1, 0, 0, 1, 1. And then I'll have it be all off. 1, 2, 3, 4, 5, 6, 7, 8. And for this last one, I'll just have something random. We'll see what we get. And by the way, if you put in more or less numbers here, I think it'll still work. You just might have an error that it's more like a logic error. 1, 2, 3, 4, 5, 6, 7, 8. I don't think you'll get a compile time error. And then end case. And then end my always block. End module. And now, because things always work the first time, I'm going to go ahead and open elaborated design, new elaborated design. Okay. Save project, sure. What do y'all expect to see? Quick. What do you think you'll see? What do you think you'll see?
Error.
An error! Yay! Y is not declared. Lab 9 not found. Okay, so let's see. So Y is not, yes, because this is always at. I change this to Y0, Y1. That's right.
Maybe it's going to be two different declaration methods for between X and Y.
That should be okay. They don't have to be the same. You can definitely mix them up. Lab 9. I called it Lab 9, and it is Lab 9. That should work. Let's see if it gives another error. Okay, but while it's compiling, if I don't have the errors, what do you expect to see? It starts with a and it ends with an ooks. Well, that was the abbreviation. It starts with a multi and ends with a plexer.
Oh,
Okay, set property, this is telling me, whoa, 32 critical warning messages. Okay, so these usually mean there's something wrong with my constraints. Let's check out my constraints. And there are my two muxes. So that works.
Still generated something despite the warning?
Yes, and let's see what my problems are. I always make mistakes in the constraints. Let's see, messages. LED 0. Oh, I did not uncomment out the LEDs.
You created your constraint file that's already included.
Yes.
Oh, wait, no, did you copy and paste it? I think I was looking.
Yeah, I copied and pasted it.
Okay, from the file you gave us.
Are they commented on there?
No, I'm trying to see which sections, because I'm not going to copy and paste the whole thing.
Oh, you only need the switches and the 7-segment display, and I included the decimal point as well, and then the AN that comes after that.
Oh, yes.
So it's the 7-segment display section. So I think that my errors were all those constraints, so I think I should be able to compile it now. So I'm going to generate bitstream, save project, okay, and I'm going to pause so that if you're watching this, you don't have to sit through for 5 minutes while it compiles, and if we're lucky, I'll remember to start recording again. Chances are we will not be lucky. I remembered to record. So it said bitstream generation successfully completed. That's nice. That's unusual. Open implemented design. I could, this is probably what you're talking about. So if I click on open implemented design, it gives you this.
That's what I was wondering.
Yeah. Yeah. No, that's not what I was talking about with the running the simulation. This is this. And its title is CLBLM_R with some other stuff. I'm currently showing you row 87, column 74. It's definitely colorful.
So what is this?
What is it?
It's like the FPGA. What's going on?
I have no idea. Let's see.
It's like when you zoom, like I can zoom in all the way and I can see the mux gates in it.
Oh,
Just keep going and keep going.
Cool. I guess so. So where would they be? Like where the variables are? Right there.
Is that where it is?
I don't know. And now I'm on the internet forever just saying, I don't know. But I don't know. But that looks like the 7-segment display right there. And let's see, these look like I would say they're the switches, but then I don't know why there's 4 sets of them. I don't know. I'll see if I can find out and let you know. But since I don't know right now, I won't spend any more time on it. Instead, I will. Well, what happens if I run implementation? Okay, I don't want to do this. I don't know what I'm doing. So rather than just play around, which I will do on my own time, I will do what I do know how to do, which is open Hardware Manager and open Target, Auto Connect, and you can find it. It's right here. I knew you could do it. Okay, program device, program. All right. So currently I have my switches are my X's and my Y's are both at 0. So it should show me my 0 character, which was everything filled in, and at the 0 display. And for those of you who are playing our home game, it has what it's showing me on the screen is, or on the basis board, is there are 4 displays. And I have, right now, I have my X switches off. They're both off, and my Y switches are both off, and it's showing me this. So it's showing me exactly what I would expect it to show. In the 0 display, it's showing what I said should be number in 0. And now if I leave X where it is and change Y, it should keep the display in the same place, but just change what it's displaying. So if I do 0, 1, I should get an R, and I realize now I did not make the best R. It looks like this, which looks more like a capital gamma without the decimal point. Next time I want to make a lowercase r, I'll use the middle. I'll make it lower like that. I'll make it smaller like that. And then if I have 1, 0, they were all supposed to be off, which it is. And if I have 1, 1, I said something random. Let's see what we get with 1, 1. I get, ooh, I like that. It should be a letter or a number. It is this character. That should be something. And now if I change my X switches, so I'll leave my Y switches like that, and I'll change my X switches to 1, 1. What should happen? If I change it to 1, 1, my X switches to 1, 1. What do my X switches do?
They change which of the displays
And so which would 1, 1 be?
leftmost.
Yeah. That's how I set mine up. And sure enough, that's what happens. I get this. All right, so everything appears to work. And let's see if there was anything else in the lab that you needed to know. We talked about the case statement and how it worked. We did some extra stuff. We did... Oh, I was going to do a test notes just for fun. So right here under simulation, I'm going to Lab 9 TB, which I just made, and I'm choosing it to set as top. And let's see. I need anything that is an input to be a reg. Anything that is an output, I need to be a wire. I'm going to have to come back and figure this out because I can't do it off the top of my head. I'll have to think about it later and do some more with it. So I'm not going to do this right now. So now going back to the lab.
When you use the test bench and put TB in the name, is that just common practice, or do you have to do it?
You don't have to do that. That's just seems to be what people do, so I do it. Okay, so Verilog code, constraints file, program the board, return the equipment and any extra supplies to their proper places. The proper place for this is in my office, and you're welcome to use it if you ever want to use it. That's fine. Did you use a case statement? If not, what Verilog construct did you use? Oh, and then here's the seven segment display schematic. All right, so any questions? All right then. I'm going to stop the recording. I'm going to play with the test bench while I'm here, and then that's what I'm going to do.